Lastly, folks, let's derive the base amount formula. Which is given by price is equal to C minus G, Vj to the n plus G. We get to this place by starting with the price, the basic price formula, which says that P is equal to FR A angle NJ plus CVJ to the N. This time replace A angle NJ by its formula. So price is equal to FR 1 minus Vj to the N over J plus CVJ to the nth power. Next, since FR is equal to CG is equal to GJ, let us replace this FR by GJ. I want something that involves the base amount G. So replacing this, we get GJ 1 minus Vj to the N over J plus CVJ to the N. These J's will cancel, leaving me with price equals G minus G Vj to the N plus C Vj to the N. Or, gathering the Vj to the N terms, I get C minus G Vj to the N plus G. So it's an alternate formula for price. It's called the base amount formula. And I would like to take this formula apart and explain what's going on here. So let us first begin with G. What is G? G is the base amount. It's the present value of an annuity paying the coupon, which are CG, forever. So basically it's a perpetuity, paying a coupon of FR equals CG, and it's the present value of that perpetuity. So let me draw a timeline. That should make it very clear. Here's time 0. At time 1, it pays CG. At time 2, it pays CG. And this goes on forever. And this present value here is equal to G, right there, of this perpetuity. Next, let's look at this GVJ to the N term. Well, the fact that I see a Vj to the N there implies that I'm discounting. So what am I discounting? Let's draw a timeline. GVJ to the N. Let me draw a timeline for this. Forever. Again. Time 0, here's time n, here's time n plus 1. If I have payments of CG, CG, and so forth, beginning at plus 1 and continuing forever, the present value of that perpetuity, it's a deferred perpetuity, the present value here would be G. But I'm not looking for the present value at time n, one period before the first payment. I am looking for the present value at time 0. So I better discount that G by multiplying by Vj to the nth power. So that GVj to the n is the present value of a deferred perpetuity paying CG forever. So the next thing I want to do is take the difference between G and GVj to the n. So I'm combining these two terms to see what's going on. When I take the difference between this G and this GVj to the n, I see that all the payments beginning at n plus 1 and onwards will cancel. This minus this is simply equal to the first n payments, because all these payments from n plus 1 onward have canceled. So I am left with these n payments of CG. So let's write that. G minus GVj to the n is equal to a present value of the payments, of the coupon payments of CG from t equals 1 to t equals n. So when I look at this formula, price is equal to G minus GVj to the n plus CVj to the n. It makes sense to me now, because this is the present value of the coupon payments from 1 to n, and this C is the redemption amount at n, and we are taking its present value also by discounting n places. So this is the alternate price formula. It's called the base amount formula, and when you look at it like this, it certainly makes a whole lot of sense. Next, I would like to go to the problem on the bottom of page 5. Let me just pull up my page 5. By the way, this was page 5A that we were working on just now. This was page 5A. So let's bottom of page 5. I see a problem there. It says n equals 8 years. M equals 1 coupon payment per year. So annual coupons. The redemption is 2338. The yield rate is 0.09. The coupon is 63. Find the price P. I would like you to do this problem 3 different ways before you come back on Monday. First, please use the basic price formula. P equals FRA angle NJ plus CVJ to the N. Secondly, do the same problem by using the premium discount formula. P minus C is equal to C G minus J A angle NJ. And 3, please use the base amount formula, which says P equals C minus G VJ to the N plus G. And make sure you get the same price for all 3 methods. Thank you, folks, and have a great weekend.